Easy to do. That happens.
All right, so we are on day 3-4 of the rational package. So you should be turned to the day 3 plus 4 on the rational package. Correct? Now, so far, when we have seen a problem like this, what has been our strategy? If you think way back to Tuesday, what has been our strategy to try to solve a problem like this, to solve for x?
The same denominator?
Yeah, get common denominators on the left-hand side, so then we can write it as a single fraction and cross-multiply. So let's go through that. With this first fraction, what do we need to multiply the top and the bottom by?
X.
Yeah, we multiply by x.
Well, can you just add 2 to the one side?
No, we're not allowed to do that.
Okay.
Good thinking, though. Now, what about the second fraction here? What do we need to multiply top and bottom by? Yep. So that would leave us with 5x squared over, let's just write this as x plus 2 plus 2x plus 4. If we distribute this 2 to the top of x plus 2 plus 5. Now we have added across 5x squared plus 2x plus 4. We've rewritten 5 as 5 over 1. We've cross-multiplied to solve. This is what we did on Tuesday, right? We wrote the left side as one fraction, and then we cross-multiplied. So when we cross-multiply 1 times all the junk on the top left, 5x squared plus 2x plus 4 equals 5x times x plus 2. So when we go to simplify all of this, now let's just go back to our algebra skills. We distribute that 5. Now if we subtract 5x squared from both sides, those would cancel out. And then probably we want to bring that 2x to the other side, so we have 4 equals 8x. And x equals 1/2. That, someone have a question or a comment?
Can you zoom out for a second?
Yeah, sure. This was what we talked about on Tuesday, and I know we haven't had a lot of practice at it yet. Kind of your homework for Tuesday evening, since we did the test review Tuesday in class. On Tuesday evening, you're supposed to look at the back side of day 2, but I have a feeling that we have a lot of back sides that are not done. Would that be fair to say?
More than fair.
Yeah, that's okay. But this is what the skill that we practiced on Tuesday. And like we kind of talked about in class, this is not a new skill. Like we've been doing this stuff, getting common denominators and cross-multiplying, since like middle school, but we just haven't been doing it when we have like x plus 2 as a denominator or different things like that. So kind of, I guess this could be considered our warm-up. Why don't you guys go ahead and do number 2 on your packet? We're going to go a little bit out of order. Why don't you do number 2? That was just number, I think, the very top one on your packet. Why don't you guys do number 2? Number 2 is looking good because I think we already have common denominators, don't we? Yeah, we do. So you don't even need to try to get common denominators in number 2. yeah, we can combine and write it as one fraction across one point. Yep. You don't even have to try to mess with the denominators. They already are the same. I'm going to write number 2 up here. Do you have a question about that?
Yeah.
Okay. Hopefully it'll. Keep working. You can check your work as I. Yep. Yep, there are. So if we bring everything to the other side.
So is that where you just
Oh shoot,
do the
that's where I messed
circle
up.
thing?
Use quadratic formula to find Why do you subtract 5 minus?
No, it's 10.
Yeah. This is just 10.
Yeah.
I messed something up. Here it should be negative 10 plus 2x. There we go. What am I missing? Why is this minus 2x? It is plus, because this is a negative 2 times a negative x.
Where'd you get the negative
So
x
then wouldn't
from?
it be negative 10?
Right here?
Oh, yeah.
It's sloppy, but it does. Yep, there's negative 10. This is what we should have when we factor. Let's see, negative 15, positive 5, negative 3. X would equal negative 5, positive 3. Yeah?
Like right in the start, like the second step, where'd you get the negative x from?
Right where?
Like right there, like
Right
where
here?
your finger is. Like x, oh, and then you minus.
So here I cross multiplied.
Oh, okay.
So if you start on the top, that stays on the left.
If you start on the, it doesn't make a difference. I mean, I could have written this.
Oh, right. Because,
You know what I mean? And we already had common denominators, so I just combined them. Yeah, Faith?
I did it where, like, I got 2x to one side and everything else, and then I subtracted 2x, so that's how I got the negative 2x plus 15.
Oh, yeah. So you had a negative x squared up front then.
Yeah.
Okay. Yep, that would work as well. I don't like having a negative x squared up front. I think that's tricky for me, but if that makes sense to you, that totally is fine.
Like I had negative x squared, negative
Yeah.
2x plus 15.
Yeah, yep, give you the same thing. Now, when we look at our x values, we want to make sure we're checking our answer. If we put negative 5 in, if we looked at original equation, if we put negative 5 in with those denominators, does that mess anything up? Do we get 0? Nope, we would get 10. Yeah, we'd be, sorry. Yes, we would get 10. No, it wouldn't mess anything up. You're right, Faith. And if we plug 3 in, then we're still all set, right? So these two x values would be good for our answer. Questions on that? That's supposed to be, again, kind of a review, remember what we've been talking about type of thing. Good? Sweet. I think we need more practice on it. I don't think we practiced it a whole lot. Now, what we're going to look at today, the new concept that we're bringing to the table today, is another way to solve problems like this. And you don't have to, what I'm about to show, you do not have to use It is the strategy that I show on the key. So if you look at the key and see a different strategy, then that would be why, because I'm showing the new thing that we're learning today. But you'll still end up with the same answer. I think to combine those two fractions into one and then cross multiply is probably the easier option. But what we're going to look at today is that we can just clear the fractions. Okay? This is the type of problem where I think clearing the fractions, this new skill today, is the easiest, or actually is helpful. When we have a problem where it is all numbers on the bottom in the denominators, then there we go. Then clearing the fractions or clearing the denominators can be very helpful. And what we want to do when we look at these denominators, we want to see what the least common multiple of these numbers are, the LCM. Does anyone remember, or could anyone tell me what the least common multiple of these three numbers are? Yeah, right?
2.
What?
14. It's multiple, not factor.
You're thinking greatest common factor. Least common multiple, like multiples of 7 would be 7, 14, 21, 28, and so on. The least common multiple of those three numbers would be 14.
Plus 2 doesn't go into something.
Yep, that also is true. So we want to multiply this entire equation, come on, by 14, technically 14 over 1, because this will clear our denominators. So if we're allowed to do this because if we multiply the whole thing by 14, then like our both sides of the equal sign even out because both sides have a multiple of 14 in them. So let's think about it for a second. If we multiply everything by 14, we just look at this first term, what would this first term simplify to? Before, we don't want to distribute the 14 to the 2x minus 3. But right now, looking at this 14 and 7, what would this first term simplify to?
2 over 1.
Yeah, just 2x minus 3. So we cleared out that bottom fraction. What would the second term simplify to? We have 14x over 2. 7. Just 7x. Yep. Hopefully we start to see a pattern of what happens when we multiply by the LCM. So we have 2x minus 3. We clear that denominator. Minus 7x. And then what would this other side of the equal sign, someone from the back row, what would that just simplify to? Well, if we have 14, this is technically what we're looking at on the right side of the equal sign. Then what would that simplify to? This x plus 3. So, again, this is an easy strategy to clear the denominator with the whole thing is an easy strategy when the denominators are all just numbers. There's no x's involved or anything like that. You can clear the denominator, clear the fractions by multiplying by our least common multiple. Now we just solve for x. Right, so we have 4x minus 6 and 7x equals x plus 3. Let's see, we have 4x and negative 7x. Now let's see what probability is this. I think you've seen clearing the denominator before. Or is that something that's totally, no, we've never seen this idea of clearing the denominator? Now, why don't you guys go and try number 1. That's just like that example that we had. And you should be able to see what the least common multiple is of those denominators. The and multiply everything by the least common multiple. What number do we want to multiply this whole thing by?
6.
Good.
8.
Yeah. Whoever said that. Got a lot of the work on the board, but I'd like you to try it on your own first. So 10 more seconds. What does x end up equaling? I heard somebody say it. Yeah, -3. Good. Any questions about clearing the fractions with those couple examples? Now, Faith asked me when we started, is this the strategy that I would recommend to you guys? When we have all numbers in the denominator, absolutely, this is the strategy I would use. Multiply by the least common multiple, clear the fraction, or clear the denominators, clear the fractions, and then solve for x. I think that's a great strategy. That's probably your easiest one. Essentially, that's what you would do anyway, but this is kind of gets everything in one big swoop. Now, I'm going to show an example of where we have denominators that have a variable involved, and how we can clear the fractions. This is not the strategy that I would probably use, but it's one that you get to see. The only time I am requiring you to show this strategy will be on this example problem that you're talking about. Okay?
Okay.
You guys with me? Does that make sense? Now, if you like clearing the fractions with this example I'm about to show, then that's totally fine. But we are looking at which example? Get all terms out of common denominator. This would be the third one down. So, this really, I mean, we can think about as 2 over 1. Now, what do we already know is going to have to be the common denominator? Of everything. What do we know?
X plus 3.
X plus 3 is going to be involved. What else is going to have to be involved?
X minus.
X minus 3. Yep. So, I mean, they call this clearing the fractions. It's really not a whole lot different than what we have been doing. But here's how this would go. If we look at this first term, what do we need to multiply by to get the common denominator? We already have an x minus 3, so what do we need to bring to the table here? To the top and bottom. Now with the minus 2 over 1, what do we need to bring to the table? Or what two things do we need to bring to the table to get a common denominator? 2 over 1. Yeah, x plus 3 and x minus 3. I'm not going to be able to squeeze that in. Now with this last term, what do we need to bring to the table to get a common denominator? X minus 3, yes. Now have we talked about and written what we need to do to get a common denominator with all of these terms? Have we? Did we just talk about what we need to do with each term to get a common denominator? Yeah, we did. So with that said, we are allowed to clear the bottom. Now here, I should have given myself more room. We have x minus 3 times x plus 3, or 2x minus 3 times x plus 3. Now with this minus 2, what did, again, we say we needed to multiply that by? Both of them, yes. And what about that 12? We said it was, we wrote that one. X plus, no, minus 3, yep.
Maybe that one.
So we kind of made a plan beforehand of saying we needed to multiply this first term by x plus 3, the second term by both things, and the third term by just x minus 3. And instead of writing the denominators and combining everything, we just eliminated all the denominators. Do you guys have any questions at this point?
So that's the easy version or the long version that you said?
That would be, I think this is a little more difficult. I like what we did here of just getting, the difference is with what we've been doing, we only got common denominators on one side of the equation, right? We only got common denominators on one side. We combined it into one fraction, like right here. We combined it into one fraction, and then we cross multiplied. Right, Levi?
That is right.
That's what we've been doing. Now with kind of the new strategy, this clearing the fraction strategy, we get a common denominator with everything. Not just one side, we get a common denominator everywhere. And then that gets rid of the fractions. That clears all of the fractions. So, again, you'll end up with the same answer in the end, but I think that this is a little more complicated than it needs to be. But still, it's my job to expose it to you in case you do think that this is a strategy. Now we just solve, right? We use all the same solving strategies. We have the FOIL here. Let's see, 2x squared plus 6x minus 3x minus 9 minus 2x minus 6. Oh, whoops. Backtrack. I need the FOIL first.
We're back.
Sorry, now everyone's erasing. Sorry. Need the FOIL here. We're not even done boiling and distributing yet. Have I made a mistake yet? Does anyone notice I missed a negative?
I wouldn't know if you did. I'm just following along.
No, you guys are actively participating.
Yeah, we are.
Oh, back up. We don't want to do that yet.
You made a mistake.
Thank you, Caleb. We want to cancel these out first. Why would we do that? Cancel those.
Goober? problem.
Okay. We have a positive 2x squared, we have a negative 2x squared. Let's see what else we can find. We have a positive 6x and a negative 3x. So that gives us 3x, 9, 18.
A little busy, don't you think?
Very busy. Yeah, I canceled out pretty well. Check my key, man, right track. State
That's
test,
cool
look
spot.
back through all that work.
What is that?
And next would be cool.
Did you lose your pencil?
There it is.
I know that there's a lot of algebra and everything through here, and I know that this idea of clearing fractions is not super simple, but do you guys have a little bit of an idea of where that's coming from?
Yeah.
Or is it totally like I have no idea where we're coming up with this stuff? Not following? Okay, we can talk about it
I will
in a second. We need to look at one more example, sorry.
No, I meant like for the.
Oh, right now? No, you do not need to do that right now. We can, but you will need to do that problem, but you don't need to. Sorry. One more example.
One more. Win a loss.
One more. And it brings out something that we need to be careful of anyway, no matter what strategy we use, so it's good to look at. But let's take a look at this right here. How would we factor x squared minus 8x plus 12? What would that be?
X and X.
How do we get 12?
6 and 2.
Yeah, minus 6 minus 2. So really here we have, let's think of it as equal to this right here instead. If we are trying to, oh, this is a bad example. Why is this example on here? I guess it still works. Because we're not really clearing the fractions, but like it says, for all strategies. If we needed, common denominators over here, we would multiply this first term by what? Yeah, x minus 6, x minus 6, and this side by x minus 2, right? To get common denominators. So naturally these fractions would clear. Maybe that's what we're trying to point out. Naturally, we have the same denominator. Now we only had to mess with these two terms, but we have the same denominator all throughout. So our fractions would clear. So we have x minus 6, plus x minus 2 equals 4. Even though we didn't multiply anything extra over here, we have the same denominator all throughout, so we can clear those fractions. Now we can just solve here. X squared minus 6x plus, sorry, whoops. Let's see, we would have x squared let's see, minus 6, we would need minus 6 plus 1. That'll give us minus 5 in the middle. Let's see, 2 and 3, but that would give us a positive 6 on the end, wouldn't it? Right? If we had negative 2, negative 3? Yeah. X equals, but I like that you're an active participant in solving. That's good. Now this is where we need to be a little bit careful, like we talked about earlier. We have the values x equals 6 and negative 1. Yeah, we need to kind of check
Not in the sense that I'm going to have you plug the whole thing back in. Yeah, if we look at our x values, only what our x values are, what x equals. These are what we're worried about right here. If we plug x equals 6 in, we would get 0 right here. Right? This would be undefined, my fault. That would be undefined. And also we would have some issues right here, right? Because we factored that out to x minus 6, x minus 2. So this x value of 6 would not work. So the answer that I would expect to see is just x minus 1. X equals -1, yeah, thank you. Now, I could see where someone is probably thinking, probably many of you are thinking, wait, Mr. Laman, what about x minus 2? What about the value of x equals 2? Wouldn't that not work also? Well, I see where you're coming from, because I thought the same thing. I talked to Mrs. Shoup, and she said we are not worried about, man, right on the edge of your seat, too. You don't even know what I'm going to say yet. We are not worried about what x cannot equal, right? Right now we're solving for x and finding what x can equal. We're saying x could equal 6, or x could equal -1. We're looking at this and saying, nope, x equals 6 would not work. So we're just going to cross it out and say x can only equal -1. You don't have to write, in other words, you don't have to write like x cannot equal -6. We're not worried about this right now, okay? So you don't have to write that for these. These are not in the directions, kind of as a side note. We are only worried about what x can equal. So how many of you think that you will use the strategy of clearing the fractions to solve these? A couple of you will?
Oh, yeah.
Very good answer. In some cases, yeah. Yep. Yeah. When we have, and I will totally recommend and stand by, that when we have all numbers in our denominator, it's way easier to clear the fraction when there's only numbers in the denominator. When we have numbers and letters, then it's maybe a little bit more complex, but also for some people, I mean, maybe that's what you like, Ryan, and maybe that will click a little bit better. Yeah, Trey?
You said this is the only time we're going to have to use it, though, like, to have to use it.
This is where the only time I'm requiring you to, yeah, is in those examples. So that's what I like to see in those examples, so I know that you were like trying something. But when we do these practice problems now on the rest of this page, you can do whatever you'd like to try to simplify. When I talk about these two strategies to simplify these fractions, we would have the first strategy that we're more familiar with would just be to combine the two fractions into one and then to cross multiply like we did here. There are two fractions on this side, we combine it into one and then we cross multiply. That would be one strategy. Our other strategy is to clear the fractions, which is what we looked at today. So that's our vocabulary.